Today we're going to be going over the AP Calculus BC 2004 FRQ problem number 6. Let f be the function given by f of x equals sine of 5x plus pi over 4, and let p of x be the third degree polynomial for f about x equals 0. In part A of the problem, we're asked to find p of x, the third degree polynomial for f about x equals 0. So first, we have to remember that we're not going to be using the summation notation or the series representation for sine of x because of this pi over 4, which is going to complicate things and make things a lot harder for us to solve. Instead, we need to find f to the nth degree of x when x equals 0 to 3, and we can do that by using a table. So when n equals 0, f of x is obviously sine of 5x plus pi over 4, and then the first derivative is going to be 5 times cosine of 5x plus pi over 4. The second derivative is negative 25 times sine of 5x plus pi over 4, and the third derivative is negative 125 cosine of 5x plus pi over 4. Since x equals 0, we can plug that into f of x and get these values right here. And then finally, to find the third degree polynomial for f, all you have to do is multiply these values by x minus a to the power of n over n factorial. And then a here is obviously 0 since this is the third degree polynomial for f about x equals 0. And so once we do that, we're going to get these values. The square root of 2 over 2 plus 5 times the square root of 2 over 2 times the factorial of 1 times x to the power of 1 minus 25 times the square root of 2 over 2 times the factorial of 2 times x squared minus 125 times the square root of 2 over 2 times the factorial of 3 times x cubed. And this problem is worth 4 points for getting the correct polynomial, and they will subtract 1 point for every missing or extra term and error. In part B of this problem, we're asked to find the coefficient of x to the 22nd in the Taylor series for f about x equals 0. So x to the 22nd in the Taylor series for f is obviously going to include x to the 22nd since f is about x equals 0 over 22 factorial. And this is going to be multiplied by the 22nd derivative of f. In order to find the 22nd derivative of f, we can look at the table that we made back in part A and find a pattern. So from this table, we can see that the coefficient is always going to have the square root over 2 in it. So we can add that to our coefficient. We also see the pattern of 5 to the nth power from 5 to the 1, 5 squared, and 5 cubed. And so we know that this is going to be multiplied by 5 to the 22nd. Now the last thing left that we need to do is find out the sign. And so in order to find out the sign, we can look back at this table and find a pattern. So we can see here that when n equals 1 to 4, that this is positive, negative, negative, and positive. And so we can use this pattern to find what the sign will be when x is to the 22nd degree. And so all we have to do is divide 22 by 4, since we have n from 1 to 4 here, and we're going to get 5 with a remainder of 2. And so when n equals 2, it's negative, so we know that the sign here is going to be negative. So the coefficient would be negative 5 to the 22 times the square root of 2 over 2 times the factorial of 22. And so this problem is worth 2 points in total, one for the magnitude and another for the sign. So in part C, we're going to be using Lagrange's error bound to show that the absolute value of f of 1/10 minus p of 1/10 is less than 1 over 100. So we know that we're going to be using Lagrange's error bound, which is the maximum derivative of the next term over n plus 1 factorial times the absolute value of x minus a to the n plus 1. And so we know that the interval is from 0 to 1/10 is given by the problem. And so we have to remember that when using Lagrange's error, we're going to be finding the maximum value over here and over here, and so the numbers that we're going to be using in order to get this are not always going to be the same in the interval. So first, to get the maximum derivative of the next term, which was going to be the fourth derivative, we can look back at the table that we made in part A, and we see that the fourth derivative is 625 times sine of 5x plus pi over 4. And so in order to find the maximum fourth derivative, we know that the maximum and minimum value of sine is always going to be 1 and negative 1. And so the maximum value here is going to be 1, so the maximum fourth derivative is just going to be 625. And so we know that this part is going to be 625 over 4 factorial. And then for this part, We know that since it is the interval from 0 to 1/10, that the maximum value here is going to be 0. So x has to equal 0 in order for this to be the maximum value, which is going to give us 1/10 to the 4th. And so once we multiply that out, we're going to get 1/384, which is obviously less than 1/100. And this problem is just worth 1 point to prove that this is less than 1/100 using Lagrange's error bound. For the last part of this problem, we're going to let g be the function given by g of x equals the integral from 0 to x of f of t dt. And we have to write the third degree Taylor polynomial for g about x equals 0. And so the first thing we have to notice is that it's asking for the third degree Taylor polynomial for g. And so we know that when we integrate a function, that what we get after that is going to always be a degree higher than the highest degree in the function. And so that means that when we use values for f of t, we have to use the second degree Taylor polynomial instead of the third Taylor polynomial, because if we integrated the third degree Taylor polynomial for f of t, that's going to give us the fourth degree Taylor polynomial for g. And so we can look back at the values that we got in part A, and so we're going to be using these values, except instead of using all 4, we're going to be using 3 because we're using the second degree Taylor polynomial and plugging that into our integral, and we're going to get this. And so once we integrate this, as you can see, we get the t cubed, so we get the third degree Taylor polynomial, and then we just plug in 0 and x, getting the square root of 2 over 2x plus 5 times the square root of 2 over 4 times x squared minus 25, the square root of 2 divided by 12 times x cubed. And so this problem is worth 2 points, minus a point for every extra and missing term. So again, make sure that you're careful when reading the problem, because if you had written the fourth degree Taylor polynomial instead of the third degree Taylor polynomial, you would have gotten a point taken off. Also be careful with what they're asking you for, because if this was just asking you to find the antiderivative, then you would have had 2 plus c, but since this is a definite integral, then you do not need to do that. Thanks for watching, and I hope this helped.